Okay, so I was just doing a few back of the envelope calculations to try and calculate things such as the mass of the propellant in the pipes going up this 100 kilometer structure, right? So, for instance, using a pipe of an example radius of 5 centimeters, I calculated that the cross section of that is 15.75 centimeters squared, and therefore the 100 kilometers of 5 centimeter diameter radius pipe yields 157,500,000 centimeters cubed, right, of volume in the pipe. No, so yeah, with that weight in kerosene, given that a centimeter cube of kerosene weighs 0.81 grams, the total amount of kerosene in all the pipework running up the 100 kilometer structure is 127 metric tons. So that sounds like quite a lot of metric tons, I grant you. However, you've got to bear in mind that I'm in this design anyway. Each state is arranged in kilometer stages, so there's 100 kilometer stages reaching up to the Karman line. Each kilometer stage has got to carry about a ton of fuel. That's, you've got to think of it like that, I suppose. So I mean, what you're constructing like isn't really, it's very light actually. It's really light. It's not the same massive as an aircraft at all. There's loads and loads more stuff in an aircraft than this. This is just like ring of rocket engines, so it's saying like above the stratosphere where we'd employ rocket engines, then fuel lines and cable hanging down. I can't see the cable really weighing more than a metric ton. I can't see the pipe with the fuel weighing more than a metric ton. If we're using like lightweight space grade materials also, then like I guess it could be any, it could be very light. It could be very light indeed. Maybe its lightness is actually something that might be detrimental to how it operates as well, and that's worth thinking about also. That it might snake around too much in the air current. We might have to keep it under too high a tension and all this sort of thing. It might just snap and break for that reason. That's worth taking into consideration, I think. But what I was thinking about also is that I think I've got a roadmap more or less identified to be able to actually test this, and to test this for way less than $150 billion. I mean, we could test this for millions, or maybe even not for hundreds of thousands. We'd still need rocket engines. We'd still need 100 of these things, or at least 50 of these things with rocket engines. Then we'd need another 50 or so, approximately, of dirigible structures with turbofans on them. And yeah, we could like build like what is in essence like a working prototype of this, a real working prototype of a real space elevator that really does reach to space, reaches to the Karman line, but it could end up carrying like a payload the size of a watermelon or something. It needn't carry anything, or a mobile phone. It needn't carry anything very heavy up there. I think it's just got to prove the concept. So this is really interesting, and thank you very much to Chris Smith on my TikTok, who was grilling me on my designs, grilling me on my my thinking behind this. Thank you. That stuff is absolutely essential for this sort of thing. That is, yeah, very good, motivating me to do some calculations related to this and to figure out a little bit more precisely how much it's all going to weigh. Very, very useful, that. So we have a good, now I think, indicate, or a good first step for the project. Good first step for the project is getting this working prototype built, and it's trying to find the funding to get that built. Do I think a wee diddy little space elevator, very thin, not really designed for carrying anything like a person up to space, but for, yeah, like we might put something ridiculous on it, like a little celebrity gift hamper or something, or like a message for God or whatnot, or glitter, just a bowl full of glitter and release the glitter into space or something like that, or yeah, send something stupid up to space. And we'll do all that and like make it fun for YouTube and things, but we'll do that. Yeah, like this is good. This is really, really good. Like this project though, it still costs millions of dollars. That's the thing about it. It will still cost a great deal of money by the standards of most people. But it won't cost 150 billion. And that is very, very interesting to me. And yeah, I think this is the sort of thing I should be pursuing now in the short term, and it's made the whole thing seem to me a lot more realistic. And yes, we can get to the Karman line with really just miniature jet engines and a lot of pipe and a little wire for it to climb up. As long as we've got all the other bits in place and everything's functioning. Then it's also the computer software and the programming for the engines and the drones, in essence, that the engines be attached to and they'll be supporting each stage. Yeah. Needs someone very good with programming, someone very adept with computer skills. It's another area in which I'm sorely lacking ability. I mean, I've got the mathematical ability to do these calculations, but that anyone does for this sort of thing. Maybe like some people don't, unfortunately, but yeah, the average person does, of course, for these stupid little calculations. I can figure out how rough I can in my mind, like just by like eyeing it, I can figure out roughly how much each stage is going to weigh at this point. So I mean, it'll be what, like 1.27 metric tons of fuel per stage. Right, so in addition to the fuel, the kerosene, the propellant, there's oxidizer. I don't think oxygen weighs as much as kerosene per cubic centimeter. I'd be very surprised if it wouldn't. Yeah, but at cryogenic temperatures, I don't know how much it would weigh, and then all the pipe for that. Thinking like maybe about 15 or 20 metric tons per stage. For an end result space elevator, not for an experimental prototype. But I mean, like a 10 centimeter, like 5 centimeter radius fuel pipe. What's that? Like that? It's got a meaty fuel pipe. That's more like for something like approaching a completed working model of it, or a completed working space elevator. But no, like, yeah, this is how we proceed. This is it. Start small, build up. But like, imagine seeing it though. Even a small space elevator reaching all the way up to the fucking Karman line. Now that would be worth seeing, would it not? That'd be quite a sight. It'd be the world's tallest structure for a little bit before we take it down again. Should have to do, obviously, we need to test that as well. See how that works. See stages descend through the thermosphere into the stratosphere. I'm just thinking, it's gonna like do that, isn't it? It's gonna wiggle around endlessly, and it'll just cut up the engines and things. That's what I'm predicting will happen. Unless we lower it slowly enough. All sorts of things to take into consideration. I think it was Autistic HQ on my TikTok the other day who suggested using the vacuum at the top and exploiting the Venturi effect to get the fuel up there instead of pumping all the way up there. I don't think pumping it up there is likely to be as huge a problem as people think it is. But yeah, employ the Venturi effect to suck fuel up using a vacuum basically is a very good idea. Definitely do that, I think. That's certainly something to take into consideration. Yeah. But really what's still foxing me is whether or not to pre-burn on the ground and just pipe up there and essentially open a valve at the top and have it go through a nozzle with reserve fuel tanks on the structure in case we need to detach a stage and land it, right? So yeah, it would need to function as a whole rocket engine for safety reasons, which makes me wonder whether or not we just pipe up propellant and oxidize and burn it all at the top. I don't know if it's going to be simple or not. I can answer my question maybe now. Pre-burning on the ground. Does it require one more pipe? That'd be what it comes down to. Anyway, I don't need to think about that. Yeah, I don't think. Well, I do really. I do. Pre-burn on the ground or not. It's so much more to go wrong at altitude. It's very tempting to pre-burn on the ground. Very tempting. Have in essence a very stretched rocket engine or series of rocket engines. If all you're releasing at the top is burned fuel, and all that's kept under pressure somehow, that's quite a nice design, I think. Burning at the top, messy, isn't it? It introduces complexity that I don't think ought to be in that system. But who am I to say that? Who am I indeed to say that? I'm no engineer. Oh, yes, I am. If I can think of this fucking thing before anyone else has had the idea of putting so much as a single turbofan jet engine onto a space elevator, oh yeah, I am a fucking engineer, if nothing else. Yes, I am. Of course I fucking am. If anything, by the way, I'm an engineer by the proxy being a farmer. Basically, anyone calls themselves a fucking engineer. Yes, I'm an engineer. I'm still a little bit foxed by this, though.